Hey everyone, so today we're going to talk about area between curves. Specifically today we're going to talk about with respect to x, and we'll also be talking about with respect to y. So first thing we want to talk about is basically our goal here today is finding an area like this. So an area where we have f of x is our top function, g of x is this bottom function. We want to find the area in between them. Okay, so the area between, I'll do b slash w there, f of x and g of x. Okay, so how do we find that? We see this little equal sign. Basically what we're going to end up doing, if I took, okay, the integral from a to b of f of x dx, I would end up with all the area below f of x, right? So I'd end up with all of that area all the way to the x-axis. Okay, so this would be between f of x and the x-axis. All right, well, if I wanted to just find, you're just trying to find kind of this piece right here. Wow, the yellow is not working on this color here. Let's see. You really just want to find this. Okay, so we're going to get rid of that. And that little portion at the bottom, okay, as you can see from our last picture here, would be if I took the integral of g of x from a to b. What's the area under the curve g of x? All right, so this would be between g of x and the x-axis. And we want to get rid of that so that we just have this floating area here left. All right, so in a general sense, okay, if we're trying to find area, if we're subtracting two integrals, okay, specifically, we're going to say it's the top minus the bottom. So we're going to be looking for what function is on the top, what function is on the bottom. We are going to be subtracting two integrals. If you guys remember, if you subtract two integrals with the same limits of integration, we can actually just rewrite that as a to b, and we have f of x minus g of x dx. So we can break those up, or we can actually put them together. And again, the idea here is it's the top function minus the bottom function. All right, and again, this is for dx, aka all of our equations are going to be in terms of x, and we're going to integrate with respect to x. Okay, so main idea is right here. So let's take a look. What if top and bottom switch? Okay, so what if they intersect and the top and bottom switch? Well, first of all, you have f of x, I'll do in this blue here. Oops, sorry. Okay, so that's f of x. You have g of x, I'll do in pink. Okay, so basically what's going to happen, all right, you have a couple situations going on. From a to b, okay, the top function is going to be g of x, which is in pink, okay, and your bottom function is going to be f of x in blue. So you can see in this area, if I said which one's on top, you'd say pink, bottom is blue. So that would be a setup to find R. I'll use a neutral color here. So to find the area for R, you would be doing from a to b, the top function, which is g of x, minus the bottom function, which is f of x dx. Okay, well, what happens when we get to b to c right here? So this area for s. So from b to c, okay, you'll notice they switched. We had an intersection, and now the bottom function is g of x, and the top function is f of x. Okay, so that being said, to find the area for this area S, we'd have from b to c, top function f of x minus bottom function g of x. Notice I'm using a lot of parentheses here. We want to be really careful, and we'll see in a second that we make sure we subtract the whole second function. All right, and last but not least, you've got that little tiny piece there, t, this area t. What's the top function would be pink, bottom would be blue. So again, from c to d, you're back to the top function is, what did I just say, g of x, and the bottom function is f of x. So one more time here, if you were going to do that, you would have c to d, top function, minus bottom function. Okay, so if you were adding those three things together, it would look something like, if you're trying to find the area here, let's say I said find the area between the two curves, r plus s plus t would be, you know, I'll be a little bit, we'll call it efficient here. We can do some copy and paste. So it'd be this guy plus s, okay, and then plus t. Adding those three together, okay, and just one note for yourself, if top and bottom switch, okay, we start or we need a new integral, which AKY, there's three of these instead of just one big topic where we could say, oh, f of x is always the top function, g of x is always the bottom. Okay, so that's kind of the main idea there. Obviously, we'll actually try this out with some real functions and actually integrate. One other thing I want you to notice, we used x values, okay, to separate and to have those limits of integration. We also always said dx. We're also using functions with x in it. So again, this is with respect to x, as we're top minus bottom. So take a look here at we've got some actual areas here, actual functions. Okay, so here's your general idea. We're gonna figure out where we intersect or kind of what x values we're going in between. Then we're gonna decide if we work vertically or horizontally, aka with respect to x or respect to y. So again, we're just gonna do respect to x right now. We will be talking about respect to y. All right, so everything is gonna be in terms of x. Take a look here, guys. We're going to be between 1 and 3. Okay, we want to see, is there any reason, you know, that we couldn't just do 1 on top and 1 on the bottom? And that's actually true. In this case, f of x is always the top function. G of x is always the bottom function, right? In this area, there's no switch. They don't cross over. So if we're doing top minus bottom here, it should be pretty simple setup. So how we're going to set this up, you've got f of x and g of x. You're going to go from 1 to 3. The top function, okay, that's, again, if you want to write yourself your note, this is what you're doing. All right, top function is x squared minus 4x plus 10. Okay, minus the bottom function is 4x minus x squared dx. Notice I have parentheses. That's going to impact my answer, right? Because I'm going to actually distribute the negative. So please be careful on that. That's just a warning for you. So next thing, just combine like terms, and then we'll just integrate. So x squared minus negative x squared, we get 2x squared minus 8x, and then that would be plus 10 dx. Okay, we raise a power. This would be 2/3 x cubed minus 4x squared plus 10x from 1 to 3. Okay, remember we plug in f of 3. 2/3 times 27 minus 4 times 3 squared is 9 plus 10 times 3 minus, plug in 1. 2/3 times 1 cubed minus 4 times 1 squared plus 10 times 1. Okay, so we should feel comfortable with that idea. Again, I know I'm rushing through the calculation a little bit. You should be, this is the new part, okay, top minus bottom, should be able to integrate. And then we're just plugging in f of 3 minus f of 1, and you end up with 16/3. So you can write that down. Typically, you'd have to do it by hand. Okay, so that's 16/3. So again, what we did there, guys, if you want to think of it in a picture, you found the area of f of x, which is everything below f of x between the x-axis. You found what's under g of x in the x-axis. That was this part. Okay, and you subtracted them, which gives you this area right here. I keep picking bad colors. How about that? Blue. We find that area in between. Big area minus small area, we get that area in between. Okay, let's try out a couple more examples here. So here's one we're going to actually have to draw. Okay, so we're going to try 2 more, and both of them will have to do a little bit of sketching. You should understand what these functions look like. You don't have to graph it on like a beautiful coordinate plane 10 by 10 with every point. But we need to know some key characteristics here in order to do this. So it says bounded by y equals 2 square root of x, y equals 8, and the y-axis. Okay, so I'll try to color code here. Y-axis would be this right here. And when it says bounded by, that would be in between whatever these functions are. So the area in between all these, it's going to be three things. So we've got the purple line. This is the y-axis. Y equals 8. I'll do that in blue here. That is a horizontal line at 8. Okay, so y equals 8. And last but not least, a square root in general, right? You've got something like this, you know, kind of that half quadratic. So what you need to figure out is we know it goes like this and it's going to intersect here somewhere, okay? This is the point we need to figure out because we know it starts at 0, 0, 0. If you plug that in, 0 equals 2 root 0. Okay, this is the area you're going to be finding. But we need to know where to integrate from, right? So we're still going to be doing top minus bottom. That's not really the issue. The issue is, where do I stop? I go from 0 to what? Okay, so you want to find where do these two things intersect, aka where are they equal? So where is 2 root x equal to 8? Where does that happen? That's root x equals 4, so x is equal to 16. Okay, so this happens at 16 comma 8. So we're going to be integrating from 0 to 16 since we're looking at x values for our area. Your top function minus your bottom function, hopefully you guys notice this top function here would be y equals 8. This is your bottom function, 2 root x. So we're going from 0 to 16, x values. Remember, we're not going 0 to 8 because that would be a y value. So 0 to 16 is where we're going to be spanning for our x values. Top function minus bottom function, and we're taking it with respect to x. Okay, so this should be your first step, kind of how you get those initial points. Can you set this up correctly? Then we actually integrate. So this is 2x to the 1/2. So if you want to rewrite that, 8 minus 2x to the 1/2 dx. And that would be equal to 8x minus, this would be 2/3 x to the, sorry, not 2/3. Well, yes, but 2/3 times 2x to the 3/2, right? Raise a power, divide by that new power from 0 to 16. Okay, so I'm just going to erase this and make this 4/3 if that works for you. And again, the calculation part, hopefully not too bad. You would have 8 times 16 minus 4/3, 16 to the 3/2. Remember, 3/2 means take the square root of 16, which is 4, and then cube it. So that would be 64 times 4/3. Minus, if you plug in 0, both of these would be 0. Okay, so again, I'll kind of just ruin the answer there. 128 over 3 would be your final answer. All right, so we're going to try one more here, which has a little bit of an interesting situation going on with symmetry. Okay, so take a look at number 3. Okay, number 3 will be our last one. It says, determine the area of the region bounded by y equals x squared minus 4 and y equals negative 2x squared plus 8. You can think of it that way, aka both quadratics. Okay, and we're not bounded by an axis or anything, so I'm just going to kind of draw a regular xy axis here. I'll do this guy in green. So this would be at, negative 4. Okay, facing up. All right. If you didn't know where those x-intercepts were, you could set it to 0. Your x-intercepts, if you solve this, would be at plus or minus 2. So you know that for sure. Okay, but you also need to figure out, so negative 2x squared plus 8, that would be y-intercept of 8. And then we go down to over 1, down 6 over 1, etc. Long story short, it actually ends up hitting at those exact points. Okay, so your area in between is actually going to kind of be this football shape here. And how do you know, sorry about my coloring, how do you know where they intersect? Let's say you were like, okay, but why do they intersect at that place? Just set them equal, right? So when is x squared minus 4 equal to 8 minus 2x squared? You would get 3x squared is equal to 12. X squared is equal to 4. So x is equal to plus or minus 2. So they actually both have intercepts at negative 2, 0 and 2, 0. And that's where they intersect. But again, all you really need to do here is set those functions equal, get where they intersect, and that's going to, again, give us our x values for where we're integrating. Okay, so as we set this up, top minus bottom does not change. Entire time, we have that purple is on top entire time, the green is on the bottom. Okay, so when we set this up, we're going from -2 to 2. Top minus bottom is what we're doing here. And our top function is purple. That was 8 minus 2x squared. We are subtracting the bottom function, x squared minus 4 dx. Okay, so again, combine some like terms here. Okay, that would get us 12 minus 3x squared dx, which gives us 12x minus x cubed from -2 to 2. Okay, and I'll just kind of ruin this for you. You would plug in 2, subtract -2, you get 32. I wanted to show you one thing here because I want you guys to notice this. That would be the final answer, perfect way to do it. Here's another thought for you. Okay, what if you noticed, and I hope you noticed, that this whole area over here, now my drawing isn't perfect, but this is symmetric. Do you guys see that? So if you split this in half, this would actually be the exact same area on the left and right of the y-axis. So one more idea for you, you'd get the same exact answer, is with symmetry, okay, you could actually set this up as from 0 to 2, okay, what's the area, and multiply it by 2. So 2 times, you're still doing top minus bottom, oops, 2x squared minus x squared minus 4 dx. Okay, but notice you could set it up this way. All right, why would that be an advantage? Well, it's just kind of nice. You end up with 2 times 12x minus x cubed from 0 to 2. And when you plug these in, you know, they're two numbers you have to calculate. It's kind of nice when you have to plug 0 in because then it just goes away. So you'd be plugging in 2. You would get 2 times 16 because this area is half of the whole area, and you would get 32. So I just wanted to give you that idea. You definitely don't have to choose that, but if you saw that happening and you saw that symmetry, it's a good way to actually kind of alleviate some of the algebra since you get to plug in 0 in this case. So we'll save number 4 for class. Besides that, if you guys have any questions, please let me know.